So functions f and g are defined in the question. Part 1 asks us to explain why the composite function fg doesn't exist. So to do this question, we'll need to know what's the criteria for composite function to exist. For fg to exist, then what comes out of g, which is the range of g, alright, needs to be a subset of the domain of f. Okay, so for this to happen, we'll check what the range of g is and what the domain of f is. Domain of f is directly given in the question, since x are all real numbers excluding 1. So domain of f will then be real numbers excluding 1. As for range of g, we know that this is a linear graph, and since x takes all real values, then the range of g will also be all real numbers. So as can be seen here, the range of g, which is all real numbers, is not a subset of the domain of f, since 1 isn't a subset of the domain of f. Alright, so from here we can conclude that fg does not exist. If you are unsure how to find the range of g and domain of f, you can always key in this graph into the GC to find out the range visually. Alright, as for part 2, find an expression for g f x, hence or otherwise find gf inverse with x equals 5. Alright, so first we have to find gf x. So to find this, we have to sub function x into function g. So g is 1 minus 2x. Our x will become function f. So it will become 2 plus x over 1 minus x. Alright, so this part will be basic algebraic manipulation. We'll multiply the 2 into the numerator. We have 4 plus 2x over 1 minus x. Next we'll combine them. Note the change of sign because the negative times into the numerator with the bracket. Alright, so now we're equal to 1 minus over 1 minus x. This can be simplified into negative 3 minus 3x over 1 minus x. Alright, so from here we will see that gfx, if we hit over this side, then gfx will equal to, factorizing out negative 3, we will have 1 plus x over 1 minus x. Alright, and then minus sign on the negative 3 can always be brought into the denominator, so we will have over x minus 1. So here is our gfx expression. Alright, then the next part we have to find gf inverse. So I have a new sheet of paper. Since we know our gfx, to find inverse, we always let our first function gfx equals to y, which will then equal to the original function of gfx, 3 times 1 over 1 plus x over x minus 1. Alright, next step we'll be making x our subject. So what we can do here is times the x minus 1 over, we'll have xy minus y times 3 plus 3x. Alright, then we will make our x subject by shifting all the x terms to the right hand side. So we have 3x minus xy. We can factorize out our x here, leaving 3 minus y. Alright, and the left hand side will be the same. Then our x will become subject when we have negative 3 minus y over 3 minus y. Alright, so up to here, this side will be equal to gf as a function of y. Then we can convert it into gf inverse x, which will equal, substituting all the y with x, and we will have our function of gf inverse. Alright, next, to find the value of gf inverse when x equals 5, that will be rather straightforward. So we will sub in the value of x equals 5. So for the numerator, we will have negative 3 minus 5. Denominator, we have 3 minus 5. Alright, so this will equal to negative 8 over negative 2, which will equal to 4.